Hi, this session is on revision on the area of some shapes that we have covered in our topic. These will include things like rectangles and triangles. Now, it's important to be able to identify what shape is given to you. And with these two examples, we can see they are quadrilaterals. This one here, we can see is a square, and we know the properties of a square. And a key property is all the sides are equal. And here we have a rectangle, where the opposite sides are equal. And it's important to identify what shapes we have, because when it comes to calculating the area of these shapes, we have to choose what formula we will be using. So with the square, now I've put in some measurements and we have to calculate the area. We know that all the sides are equal. So when setting up your working out, you must write the formula first and then use that formula to work out the area. So the area of a square, it's similar to a rectangle, but we know a square has all equal sides. So this length, which is 2 centimeters, is also the same length on this side, which is also 2 centimeters. So instead of having length times width, we have L times L. It must be the same variable, indicating the sides are the same length. And we can write this as L squared. So now what's the length of this square? We can see it's 2 centimeters. So we have A is equal to 2 squared, or 2 times 2, and therefore A is equal to 4 centimeters squared. And we know we have to put that 2 here, indicating there are 4 squares that make up the area of this square here. And we wanted to quickly show that, if I measure this, so 1 centimeter and 2, so I'll break it in half, and the same thing here, we can see we have 1, 2, 3, 4 squares. Imagine they were perfectly even. That's what we have. With the rectangle, because a rectangle has different lengths, it's got a length here that we call the length because it's the longer side, but then the smaller side is called the width. The formula for the area of a rectangle is area is equal to length times width. And now we substitute the values in for L and W. L is 4, the longer side, so area is equal to 4 times W, which is 2, and therefore the area is 4 times 2 is 8. Now please don't forget your units, centimeters. Because we found area, we put that little 2 there, which means squares. So 8 squares make up this area, and we can show that by, if I've got 1 centimeter, 2, 3, and 4, if I draw that up, so 1, 2, 3, 4, and we have 2 across, so 1, 2, I'll put it halfway. We can see how 8 squares make up the area of that rectangle. Now with our next two questions, what shapes do we have? You notice that we have 2 triangles. Now when it comes to a triangle, the formula for the area of a triangle is, we must remember this formula, area of a triangle is equal to base times height, and we divide that by 2. And the reason why we have that formula, just to recap, is because a triangle is actually half of a rectangle. If I just draw a rectangle down here, half of a rectangle, if I did it this way, is a triangle. So it's a rectangle has length times width, and if I halve that, it gives me the triangle. But the thing is, a triangle is a bit different to a rectangle. Instead of a length and a width, we now have a base and a height. And it's very important to understand what the base is and what the height is. Now the base, just like anything, the base is the bottom part of the triangle. And to know whether it's the base or not, the height of the triangle hits the base. If we have a look at the first triangle, we've got this dotted line, and can you see this right angle here? This right angle is indicating that this line here is vertical. The height of a triangle must be a vertical line from the top straight to the bottom, or the bottom straight to the top, and the right angle indicates that. It's telling us that this vertical line is perpendicular to the base, so it hits the base at 90 degrees. That's how we know that 4 centimeters is the height of the triangle, and 12 meters from here to here is our base. So now we substitute this into our formula. Area of a triangle, I'll just put it here, I haven't got room down beneath it, is base, so 12 times height, which is 4, and we halve it. Now, let's do this mentally. We don't need a calculator. 12 times 4 is 48 divided by 2. And because when we divide by 2, we're halving something. So what's half of 48? We end up with 24. Now, what are our units? Meters squared. So 24 meters squares make up the area of that triangle. So it's quite a big triangle. Now, this one down here, it looks a bit different to the top one. Where is the height that they're giving us? We can see that, well, we've got a vertical line here, and here's the right angle indicating it's a vertical line, and it's going from the bottom straight to the top. Now, you can see how the triangle, the base ends here, and at this point and that point, and from here to here, it's 9 meters. Now, this vertical line here, it still hits the base, where the base is located. So if I extended my base, you can see how it hits that line there. So the height is 10 and the base is 9. So once again, write the formula. So area of a triangle is base times height. And we have it. So base is 9 times 10, which is the height. And we have that. So area is going to be 9 times 10 is 90 divided by 2. And half of 90, area is 45 meters squared. And we're done. And when you're doing a working out, try and have it all underneath each other, each step. I'm just squeezing it in. So with this triangle, can you see how they have given you 3 measurements? You don't have to use all 3. You have to know which one's the base, which one's the height. Now, the trick is, we know the height is a vertical line that hits the same level as the base. In this case, it's this line here, and we can show it with a right angle. This 10 meters, we don't actually need it, because this 10 meters, this line here is not a vertical line, it's diagonal. So it is not the height. So use 5 and use the 13 as your base times height. With our next question, what shapes do we have? We can see that it is a parallelogram. So a parallelogram is not a rectangle because the corners are not 90-degree corners, okay, the angles inside the parallelogram, but the opposite sides are also equal. And see these arrows here? They are telling you that these two sides are parallel, as well as these two sides. So that's how you can tell if it's a parallelogram. Now, a parallelogram can actually be cut up into a rectangle. So the formula of a parallelogram is really easy. It's similar to a triangle and a rectangle. That is, the area of a parallelogram is equal to base times height. Instead of length times width, a parallelogram has a base and it has a height, just like a triangle does. But we don't divide it by 2. Now have a look at this. Where is the vertical line indicating the height? We can see that there's the right angle here, and we can see that we've got 8 millimeters going from the bottom straight to the top. And it hits the base. It hits the same level as the base, which is what? 6 millimeters. So all we're going to do is go 8 times 6 and we're done. So the area of that parallelogram is going to be 8 times 6, and 8 times 6 is simply 48. And our units were millimeters squared. That's how easy it is. Let's try the next one. So we have a look. Once again, we've got the vertical line there indicated by the right angle, and it hits the base, and the base is 7 meters. So what's 3.5 times 7? So first let's write it out. So that's A. So for B, the area of a parallelogram is base times height. Area is equal to 3.5 times 7. And to work this out mentally, well, just what's 3 times 7? 3 times 7, I know, is 21. And 0.5 of 7. What's half of 7? So I'm going to plus half of 7. Half of 7 is 3.5. And that should give me the answer. So 21 plus 3.5. 21 plus 3 is 24. And we've got 0.5. So we added in. Area of that parallelogram is 24.5 meters squared. Now this very last one here, C, You can see how they're trying to trick you. They've given you 3 measurements. Remember, all you need is the base and the height. Always, your first tip is, what's the height of this triangle? Now, see 2.9? Doesn't this look like a vertical line from here to here? And it does. But the problem is it hitting a base at a right angle? No, it isn't, because it hits this base here, which is 1.4 centimeters. But the problem is it's not hitting it at a right angle. Where do you see the right angle? Here it is, okay? So if you can rotate this, remember you had this on a piece of paper on your exam, so you can rotate this or tilt your head. I can see that this line here where it's got 2 centimeters, there's my right angle, and it hits the same level as the base, which is 1.4 centimeters. So it's 1.4 centimeters. So that 2.9 centimeters, I don't need it. It's not the base or the height. The height is from the bottom straight to the top. It's a vertical line that hits the base or the level of the base at 1.4 centimeters. So all I got to do is go 2 times 1.4. So for C, once again, the area of a parallelogram is base times height. Area is equal to, base is 1.4, height is 2. So 1.4 times 2. And so the area is, and that is something you can work out. And don't forget your units are centimeters squared.